Let's say we have a line. Now I want to find the slope of that line. I'm going to take 2 points on the line. Doesn't really matter what 2 points. Make a triangle. What did we call this? Remember we called it what? The rise?
Overrun.
Yep. And this is the run. So the slope, the definition of slope, we use, by the way, we use the letter M for the slope, is the rise over the run. The rise over the run. So if you have 2 points, this is point 1, this is the x value for point 1, this is the y value for point 1. This is the x value for point 2. This is the y value for point 2. So what is the rise? When you look at it in terms of y2 and y1, the rise is that little piece right here between y2 and y1. So isn't that y sub 2 minus y sub 1? This y value minus this y value, that's what the rise. And the run, it's this distance from here to there. What is that? That's all of this minus all of this. X sub 2 minus x sub 1. A lot of times we write that also the change in y over the change in x. In math, that's a lot of writing, change in y over change in x. The word change in math, we use delta. Delta y, delta x, little triangle. Delta always means change. Change in y over the change in x. So if you're in a science program and you hear the word delta, that means the difference, the change in them. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the equation we're going to be using to find the slope. The only time you cannot use this, the only time, is when? Anyone? When can we use that equation? When x sub 2 equals x sub 1, you cannot use it. So this is x sub 2 does not equal to x sub 1. Why? Because if they are equal to each other, what's x sub 2 minus x sub 1? If they are equal to each other. Let's say they're both 5. What's 5 minus 5? Can you divide by 0? No. 0 on the bottom is always a problem. So that's the only time we can't use that equation to find the slope. When these two, x sub 2 and x sub 1, are equal. And the only way they'll be equal, the only time, if the graph looks like this. Because the x value for both of them will be the same. So if you have a vertical line, you have the same x value, then you can use that equation to find the slope. We'll do some examples here, but before I get to that, there's 4 possible outcomes to your slope when you calculate the slope. There are 4 possible choices that you can have. You can have positive slope. You can have a negative slope. I'll give you an examples. You can have a 0 slope. And you can have an undefined slope.
So is undefined going straight up and down?
Correct. So a positive slope, as you go from left to right, the function is rising, like the plane taking off. The height is increasing. All these are positive slope. Notice as you go from left to right, what is happening to the y value? It's getting what? Bigger and bigger and bigger. What's a negative slope? A negative slope, as you go left to right, the function is falling, it's coming down. All of these have negative slope. Because as you go left to right, the y value is dropping. Notice here, as you go, just pick this one. As you go left to right, here's the y value, and there's the next y value. It's getting bigger. Pick any one of these, like this one. As you go left to right, look at the height, and look what happened. As x increases, it looks like the y value is dropping. What's a zero slope? There's no change in the height. All of these have zero slope. So horizontal lines always have zero slope. This is y equals to 1, y equals 2, y equals 3, y equals negative 1, y equals negative 2. All of these have a zero slope. And what's an undefined slope? Undefined slope, a line that goes up and down, because you're dividing by 0. All these are undefined slopes. This is x equals to 1, x equals 2, x equals negative 1, x equals negative 2. All these vertical lines have an undefined slope. So positive slope, negative slope, zero slope, undefined slope. That's it. There is no other choices. Let's take some examples and calculate the slope through them. Here is the problem. Find the slope of a line that contains the points. Let's pick some points here. 1, 2 and 4, 3. Find the slope of that. Period. After we finish with that, let's plot the points and then sketch the line. So this is my question. Find the slope of a line that contains the points 1 and 2 and 4 and 3. Plot the points and then sketch the line.
So in this case, does it matter which one we use as y2?
Correct. Definition of slope, if you know 2 points, it's y2 minus y1 over x2 minus x1. I'll do them both ways just to show you. It doesn't really matter. Here we go. That's what I'm going to use. So the first time I'm going to do this, here's the 2 points, 1, 2, and this is 4, 3. I'm going to make this my point 1, and this is my point 2. The second time I'll flip-flop them. So if this is point 1, then this is the x value of point 1, this is the y value of point 1. That's what x sub 1 is. The x value of point 1, the y value of point 1. I'm calling this point 2, so this is the x value of point 2, that's the y value of point 2. What is my slope then? y sub 2, which is 3, minus y sub 1, which is 2, over x sub 2, which is 4, minus x sub 1, which is 1. 1/3. Positive slope. Now let me redo the problem. But this time reverse them. I'm going to call this one 0.2 and this is 0.1. So this becomes the x value of 0.2, that's the y value of 0.2. The x value of 0.1, the y value of 0.1. The slope m, it's y sub 2 minus y sub 1. Y sub 2 is 2 minus y sub 1, which is 3, over x sub 2, which is 1, minus x sub 1, which is 4. Negative 1 over negative 3. What's a negative over negative? Positive. Is that the same slope? So it really doesn't matter which one you call 0.1, which one you call 0.2. Your answer at the end is going to be the same. The key to remember, the first number is x, the second one is y. First one is x, second one is y. Don't flip-flop them. You flip-flop them, you're in trouble there. So we answer the first question, that's this one, find the slope. The second part of the question is plot the points and sketch the line. Let's plot them. One, two, three, four, five. 1, 2, 3, 4, 5. I'm not going to number them, it gets messy. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. The points are 1 and 2. The first one, x is 1, y is 2. So go from here, 1 in the x direction, 2 in the y direction, right here. That's 1 and 2. The second point is what? 4 and 3. 1, 2, 3, 4. And go 3 up. 1, 2, 3. We have the 2 points. Now take a straight line or a ruler, connect the 2 points with a straight line. And that's the graph, sketch the graph that you're looking for. It has to pass through the 2 points. So that's the answer to the second part of the question. Plot the points and then sketch the line. These are the 2 points and the line will have to go through them. Okay, let's try another one. So that's a positive slope. Let's look at negative slope. Sketch the line. That contains the point. Contains the points. And let's pick some points. Negative 2 and 1. And 3 and negative 5. After you finish with that, find the slope. So 2 questions again. Sketch the line and find the slope. Let me do sketching the line. I put 5 notches in each one, that's plenty. X, Y. The first one, negative 2 and 1. Start from the origin, negative 2 in the x direction, go backward 2 units and 1 up. That's this point, negative 2 and 1. The next point, 3 and negative 5, starts from the origin, go 3 in the x direction, that's right here, and 5 down. That's the other point. Connect the 2 points, and that's the graph I'm looking for. Is my slope going to be positive or negative? What do you think?
Negative.
Negative. Let's see if the math agrees with us. Since that's the first point, I'll call it x1 and y1. This is x2 and y2. Again, I could have reversed them and I'll be fine. The slope m is y2 minus y1, x2 minus x1. Negative 5 minus y sub 1, which is 1, x2, which is 3, minus a negative 2. What's negative 5 minus 1?
-4.
Try again.
Oh,
How about negative 6? Minus a minus is what?
positive.
Plus 3 plus 2.
5.
So my slope is negative 6 over 5. It is a negative slope, and the graph says, yep, it's negative. What does that mean? For every step that you take to the right, for every 5 steps that you take to the right, you're going to drop down 6 steps in the y direction. For every 5 steps in the x direction, you're going to drop down 6 steps in the y direction. This change in y over change in x. Notice your slope, negative 6 over 5. If x increases, that's positive 5. If x increases, it means go to the right by 5 steps, the y value, its negative, will decrease by 6 steps. That's what that means. So that's a negative slope. We showed you a positive slope. Now this is a negative slope. Let's look at zero slope and undefined slope. Sketch the line. That contains the following points. The points are 2 and negative 1 and 6 and negative 1. After that, find the slope. So 2 questions. This is question number 1, question number 2. What is the first point? 2 and negative 1, right? That's down here. 2 and negative 1. Go 2 to the right, 1 down. And the next point is what? 6 and negative 1. 1, 2, 3, 4, 5, 6 and negative 1. And when you connect the 2 points, that's where your graph is. Horizontal. There's the other point here. So I know my slope should be 0, but let's see if it is 0. This is x1, y1, x2, y2. M, y2 minus y1, x2 minus x1. Notice I keep writing that equation. If you write it 3-4 times, by the time you leave this room, even if you've never seen it before, it will stay with you. It will stick. Minus 1 minus negative 1 over 6 minus 2. That's a negative 1. Minus a minus is positive 1. What's negative 1 plus 1? 0 over 4, which is what? 0. So the slope of that line is actually 0. That's a 0 slope. Any horizontal line has a 0 slope. Couple more things, then we're done with this section. Let's do another sketch. The line that contains the points 4 and 2 and 4 and negative 3. My mistake. It is. Yeah, that's fine. Yep, that's fine. Find M. Find the slope. That's the second part. I had a different number in mind, but it works out fine here. Four and 2. 1, 2, 3, 4, and 2 up. 4 and negative 3 down here. When you connect them, that's a vertical line. The slope should be undefined. It should be. Let's see. x1, y1, x2, y2. Fill in the blank. What is y sub 2? Negative 3. Minus y sub 1, which is 2. 4 minus 4. What's negative 3 minus 2? Negative 5 over 0. Because of the 0 on the bottom, the slope is undefined. Can't divide by 0. You have an undefined slope. Two things left in this section, then we're done. When we say parallel lines, we talk about parallel lines and perpendicular lines. Let's look at parallel. If you look at the lines, parallel lines, they look something like this. What does parallel means?
Crossing?
They don't cross each other.
Oh.
The distance between them stays the same. These two lines are parallel. That gap between them always the same. They never cross each other. So what do we know about parallel lines? They have the same slope. They have the same slope. So in math, we go if line 1, L1, line 1 is parallel to line 2, if line 1 is parallel to line 2, then not them, then the slope for the first one, which is M1, should equal M2. So once the problem says parallel, you know they have the same slope. Now the other one is perpendicular. Perpendicular. What does that mean? They cross each other. But not any cross. They cross at what? 90 degrees. That's what perpendicular is. One goes this way, one goes that way. They have to cross at 90 degrees. If you take this, if the two lines are perpendicular to each other, if line 1 is perpendicular, that's how we write perpendicular, upside down T, perpendicular to line 2, then what? If you take the slope of the first line multiplied by the slope of the second line, the answer is -1. Always. So if you take the two slopes and multiply them out, they should equal to -1. Or you can say that the slope of the second line, it's always -1 over the slope of the first line. So let me assume these lines are perpendicular to each other. This is M1 and this is M2. They are perpendicular. I'm telling you that right now. If the slope for the first line is 2/3, what's the slope for the second line then to be perpendicular? -1 divided by this. That's a lot of work. How do you do -1 over this? Shortcut for that, flip and change sign. So if you flip this one, it becomes what? 3/2 and change the sign to what? -3/2. If one has a slope of -4, that's -4 over what? Over 1. Flip and change the sign. The other one will have a slope of what? Try again. +1 over 4. If one has a slope of 1/5, what's the slope of the other one? -5. Yep, it's over 1. We just don't put the 1. -5. You flip and change the sign. They will give you some lines and they will ask you, or points. It says this line going through these points, this line's going through that points. Are they parallel? Are they perpendicular? And you got to find the slope for each one and see if they are the same. If they are parallel. They can't be perpendicular if they're parallel. And if they're not parallel, see if they are perpendicular to each other. One example, then we're done. I have this line, line 1 passes through the 2 points. I'm just going to write it quickly. 0, 4, and 4 and -1. Line 2 passes through the other points, which is 0 and 8, and 8, negative 2. Are they parallel, perpendicular, or neither? Let me find the slope for each one. This is m for the first one. This is m for the second one. This is the top one, is line 1. This is x1, y1, x2, y2. This is the second line. This is x1, y1, x2, y2. Let's look at the first line. Y sub 2, negative 1, minus y sub 1, which is 4, x sub 2, which is 4, minus x sub 1, which is 0. So what do we have? Negative 5 over 4. Let's look at slope 2. Y sub 2, negative 2, minus y sub 1, which is 8, x sub 2, which is 8, minus x sub 1, which is 0. That's a negative 10 over 8. Can we simplify that? Negative what? 5 over 4. What do we know about the two slopes? Same slope. Since m1 equals m2, then we know the two lines are parallel. If not, then I'll multiply them out and see if the answer is minus 1. If it is, then they are perpendicular. If that doesn't work out, then it's neither. They could cross at not a 90 degree. They could cross like this, which means they're not parallel and they're not perpendicular. So it is possible to be neither. Now this example, this happens to be parallel. And that's the end of section 3.2.